Right, we're going to go over your homework for implicit differentiation. So again, with our first problem, we are still doing all of the derivative stuff that we're used to doing, and we still have to incorporate chain rule and product rule and quotient rule when necessary. For number 1, you're going to have 16x plus 2y, y prime, or dy dx, those are the same, equals 0. And then we're going to solve for y prime. So we're going to move 16x over to have 2y, y prime equals negative 16x. And then dividing both sides by 2, I have negative 16x over 2y, or negative 8x over y. Number 2, we're going to do the quotient rule with this. So we'll have the bottom times the derivative of the top minus top times derivative of the bottom all over the bottom squared. Plus, and we're going to repeat this process with the next one. So we have the bottom times derivative of the top minus the top times derivative of the bottom over bottom squared equals, and again with the coefficient it just comes down over here to the side, so we have 3y prime. Now we need to solve this for y prime. So we could divide this up into individual terms, and that's what we're going to try here. And if we do that, we're going to have 1 over y minus x over y squared, y prime, plus 1 over x, y prime, minus y over x squared equals 3y prime. And we are going to try to get our y primes together on one side and move everything else over to the other side. And when we do that, we have x over y squared, y prime, and it is negative. And we also have this term 1 over x, y prime, minus 3y prime equals, as I move that over, negative 1 over y plus y over x squared. Now we need to factor out our common factor of y prime. So y prime times negative x over y squared plus 1 over x minus 3. And what we're going to do with this is just leave this, once we divide both sides by the parentheses, just leave it as it is. Don't try to do any more simplifying to it. And all of that is over negative x over y squared plus 1 over x minus 3. Again, with this problem, we need to change our square roots into rational exponents. So I'm going to have x to the 1/2 plus y to the 1/2 equals 100. Now we're ready to do the derivative. So we have 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 times y prime equals 0. And we are going to move everything over to the other side. So we have 1/2 y to the negative 1/2 y prime, oops, don't need my equal sign yet, equals negative 1/2 x to the negative 1/2, because we are moving that. And then we're going to divide both sides by this portion here. So I have y prime equals negative 1/2 x to the negative 1/2 over positive 1/2 y to the negative 1/2. And to simplify that, those 1/2s do cancel, so I have negative x to the negative 1/2 over y to the negative 1/2. And to remove those negative exponents, we do flip everything over. So we have y to the positive 1/2 over x to the positive 1/2. And that would be as much simplifying as I would do with that one. All right, moving on to the next problem, more of the same. So the first thing we're going to do here is go through our derivatives. So we have 10x minus, and we need our product rule here. So we have first derivative of the second plus second times derivative of the first minus 8y, y prime equals 0. Now we're going to distribute our negative. So I have negative x, y prime minus y. And then after we do all of this, we are going to isolate our y prime on one side and move everything else over to the other. So I'm going to have negative x, y prime minus 8y, y prime equals. Now I'm going to subtract 10x over. I'm going to add y. And now over on this other side, we do need to factor out y prime. We have negative x minus 8y equals negative 10x plus y. And finally, we have y prime equals negative 10x plus y. All of that's over negative x minus 8y. Okay, moving on to our next problem. Now we have our e to the y power. We have to be careful with this, but let's not try to make it tougher than what it really is. We do have our product rule here. So we have first times the derivative of the second and the derivative of e to the x. So if we do our derivative of our exponent, we're going to have y prime, 1y prime or y prime. So that's going to be stuff prime times e to the stuff. So there's first times derivative of the second plus the second times derivative of the first. And the same process over here. We're going to separate that 2 and just look at our product rule here. So we have the first times the derivative of the second plus the second times derivative of the first. And then we have the derivative of our last term. Well, this one, it looks like we're going to have to do our distributive property. So we're going to have x, y prime, e to the y, plus e to the y equals 2xy prime plus 2y plus 3y squared y prime. Now let's see if we can't get all of our y primes together. This time it looks like we have more y primes on the right side than the left. So I'm going to move everything I can over to the right side, and then everything that does not have a y prime over to the left. So we have e to the y minus 2y equals, and then over on this other side we have 2x y prime plus 3y squared y prime, and then I'm going to subtract over x y prime times e to the y. Now what we're going to do is factor out a y prime, and what's left over is going to be 2x plus 3y squared minus x e to the y. And then finally we're going to divide both sides by all of this stuff sitting to the side. So we have 2x plus 3y squared minus x e to the y. And we're not going to do any more simplifying to this. We're going to leave it like it is. Okay, and so our final answer would be all of this stuff here. So for our next one, we have some trig to deal with. And we're going to do the derivative of sine of x is going to be cosine x times the derivative of x, which is 1, plus 2 times, and we're going to do the derivative of cosine is going to be negative sine 2y. But then that's going to be times the derivative of 2y, which is going to be 2y prime, equals 0. And now we need to solve for our y prime, so I'm going to have a negative 4y prime sine 2y equals, and I'm going to move the cosine x over to the other side. And again, we factor out y prime. So we have negative 4 sine 2y. And then finally, we will just divide by our negative 4 sine 2y. And that's going to be, again, all of the simplifying. You could probably cancel out those signs, but there's not going to be too much more I would do with that. Okay, more fun with trig. So we're going to do the derivative of cosine, which is going to be negative sine of the angle xy. But then we've got to multiply this, and I'm going to isolate this, times the derivative of our angle, which is going to be the product rule. So we're going to do the first times the derivative of the second plus the second times derivative of the first. And then we're going to do the same thing over on the other side. So again, we're going to have first derivative of the second plus second times derivative of the first. And here, keep in mind, we are solving for y prime, so we do need to do our distributive property. We're going to multiply that sine xy to each part. So I'm going to have negative x y prime sine of xy minus y sine of xy equals all this other stuff. Now we're going to factor out y prime. Or no, we don't have, yeah, we need to move our y prime over, sorry. So we have negative xy prime sine of xy. And then I'm going to bring over this other term minus xy prime equals y plus y sine xy. And now let's factor out y prime. So I have negative x sine of xy. And we also have minus x equals y plus y sine xy. Now let's divide both sides and we'll be finished with the problem. And some people might want to try to factor and do some stuff. I would not do anything with this. Just leave it like it is, because again, we will be substituting in values. Okay, moving on to the other side, more of the same stuff. So here, we're going to leave the 2 sitting on the outside here. And so we're going to do product rule again. We have first derivative of the second plus second times derivative of the first. Plus, and pi, keep in mind, is still just a coefficient, times the derivative of cosine, which is going to be negative sine of y, times the derivative of y. And all of that's equal to 0. The derivative of 2 pi, again, is still just 0. We're going to do our distributive property. And over here we have negative pi, I don't know why in the world I put that equal sign there. My crack's kicking. So we're going to say minus pi sine y, and all that again times y prime equals 0. So we're now ready to move over some stuff and factor out our y prime. So those are going to stay together on one side, and I'm going to factor out y prime. This 2y is going over to the other side. And so when I do that, and I'm going to do all of this in one step, or try to anyway, and then we're going to have equals negative 2y, and then I'm going to divide both sides by our 2x minus pi sine y. All right, so hopefully we're getting to see the patterns to these problems. Moving on to the next. Now we need to write the equation of the line, tangent and normal. So here, if we do the equation of the tangent line, then we can very quickly do the equation of the normal line. So let's first thing is review the equation formula. And we do need to remember that's going to be y minus y1 equals m times x minus x1. And so we know what our x1 is and we know what our y1 is, but we need to do our derivative to find our slope. So let's go through that. We're going to have 3x squared plus 2, and again our product rule. So we have first derivative of the second plus second times derivative of the first. And then we're going to take our other derivative and then equals 0. We have 3x squared plus 2x y prime plus 2y minus 2y y prime equals 0. And let's do some rearranging and factoring out a GCF all in one step. So I'm going to leave these alone and factor out y prime. And that's going to leave me with 2x minus 2y. Over on the other side, I would subtract 3x squared minus 2y. And then finally, I'm going to divide both sides. And we're going to get negative 3x squared minus 2y. And all of that's over 2x minus 2y. Now, what we need to do next is evaluate this at our given point. So we're going to evaluate y prime at the point 2, 3. And so we're going to substitute in our 2 for the first one. So I'm going to have negative 3 times 4 minus 2 times 3, which is 6. And all of that is over 4 minus 6. So we're going to have negative 12 minus 6, which is negative 18 over negative 2, which is going to give us a positive 9. So now we have everything we need to write our equation. We have y minus, and our y1 value is 3, equals our slope times x minus our x value. And so the only difference between this and the equation of the normal line would be our slope. So if we look at the normal line, it's going to incorporate all of the same stuff except for our slope. We're still going to have y minus 3 equals, but this time it's going to be the negative reciprocal. All right, so there's our equation of our normal line and our equation of our tangent line. Moving on, same process again. Now for this one, we're going to have to do a couple of steps with it because all of this is under the radical. So doing some rewriting here, we know that's x, y all raised to the 1/2. And so whenever we start working through this, we have to remember that this exponent is going with both, and so we can divide it up or we can treat it all as one thing. If we leave it together as one thing, that's going to give us 1/2 times xy to the negative 1/2, and then times the derivative of the inside, which is going to be first derivative of the second plus second times derivative of the first. And then all of this is equal to 12y prime minus 1. Now in this case, there is no way I would go through and solve for y prime. I would now at this point substitute in our values. It's going to make it a lot easier for us. So we're going to go ahead and evaluate this for 9, 1. So we have 1/2 times. If we plug in our x and y value, we're going to have 9 to the negative 1/2 times, and 9 times y prime, well, y prime, y prime's what we're looking for, plus 1, equals 12y prime minus 1. So from here, we're going to have 1/2 times 1/3, so we have 1/6 times 9y prime plus 1 equals 12y prime minus 1. Now, I sure don't want to deal with that 6 for a fraction here, so I'm going to multiply that over to the other side. So I have 9y prime plus 1 equals 72y prime minus 6. Now, I'm going to subtract 9 over to the other side, and then I'm going to add 6, so I have 7 equals 63y prime. And so that tells me that y prime, or our slope at this point, is 7. Now we're ready to write our equation of our line. So we are at the point 9, 1. So we have y minus 1 equals our slope times x minus x1. And then if we wanted to write the equation of our normal line, y minus 1 equals negative 1/7 times x minus 9. All right, more of the same, funness, woohoo. So we're going to do first derivative of the second. So we need derivative of stuff times e to the stuff. So y prime times e to the y. So there's first times derivative of the second plus second times derivative of the first. And we're going to repeat this madness over on the other side. So we have first derivative of the second plus second times derivative of the first equals 9. And again, with all this craziness, there is no way I would try to solve for y prime when I'm given a value. So let's go substitute in. So x squared, that's going to give me 9 y prime times e to the y plus e to the y times 2x, so that's going to be 6. Plus y, 0 times e to the third, plus e to the third y prime. Oh, that doesn't equal 9, that equals 0. I'm a crackhead. All right, so let's see if we can't simplify this. Well, e to the 0 is just 1, so I have 9y prime plus 6, well, that's all 0, plus e cubed y prime equals 0. And we're going to try to solve this for y prime. I'm going to subtract 6 over, so I have 9y prime plus e cubed y prime equals negative 6. Let's factor out y prime. And it looks like we have found our slope. It's absolutely disgusting looking, but it is what it is. We can't discriminate there. So you've got 6 over 9 plus e cubed. And now we're ready to write the equation of our line. So keep in mind our original point was 3, 0. So we're evaluating this 3, 0. So we have y minus 0 equals this disgusting slope times x minus 3. And again, if we wanted to do the equation of the normal, it's going to be the negative reciprocal. So I'm going to put a negative sign out front, and I'm going to flip this bad boy over, and then times x minus 3. There we go. All right, so again, the madness continues. We're going to have first times the derivative of the second plus the second times derivative of the first. And then we're going to repeat this. So we have first derivative of the second plus second times derivative of the first. And all of that equals 0. And once again, do our substitution. So we're going to have 4y prime plus, and we're going to have 4 here, plus another 4, oh my gracious, this is weirdness, plus x is 2 times 1, so another 4y prime equals 0. That is so weird. All right, and we're going to put these together, so that's going to tell me I have 8y prime, as we can actually add those together, equals negative 8. So y prime equals negative 1. So we're ready to write the equation of our line now. Y minus 1 equals negative 1 times x minus 2. And then the normal line is still y minus 1 equals positive 1 times x minus 2. For these problems, we have to find the standard form of the equation of the tangent line to the hyperbola, and they've given us that hyperbola equation. So again, we have our point. Now we've got to go find our slope, so we need our derivative. So we're going to have 18x minus 8y y prime equals 0. And again, we can solve this by subbing in our point 1, negative 1. So I have 18, and that's going to give us plus 8, y prime equals 0. And so y prime equals negative 18 over 8, or that's going to be, what, negative 9 over 4. So now we're ready to write our equation. We have y minus y1 equals negative 9 over 4 times x minus 1. Now here's where the rewriting comes into play in that standard form. We don't want to deal with that fraction, so I'm going to multiply that 4 to every part over here on the other side. So I have 4y plus 4 equals negative 9 times x minus 1, and that's going to make this process a lot easier, moving that 4 over. So I have negative 9x plus 9. And now we need x and y together on one side, so I'm going to add our 9x plus 4y, and then I'm going to subtract the 4 over to the other side. And there's our standard form. Okay, more of the same. For this other one, we're going to write the equation of the line tangent to this graph at a particular point. And so for here, we're going to go through and do our product rule. We have first, oh, my pen is saying nope. Now we're going to do this. We have first derivative of the second plus second times derivative of the first, and then that goes to 0 and it's equal to 0. So it looks like very quickly that y prime is going to be negative y divided by x. And so let's go ahead and write our equation. So we have y minus y1 equals our slope. Well, if we plug in, we're going to have y prime evaluated at negative 2, 8. It's going to give us negative 8 over negative 2, which is 4. So I have 4 times x minus a negative 2. All right, moving on to our next madness. Write the equations of the lines for normal and tangent to our given point. So again, we need to find our derivative first. They've given us everything else. So our derivative here, it's going to be great practice with these rational exponents. We have 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 times y prime equals 0. And again, no way I would go through and I would just substitute in our values. So we have 2/3. Now 8 to the negative 1/3, that's really going to be 1 over 8 to the positive 1/3, which is the cube root. And over here, 2/3 times, and again, that's going to be 1 to the negative 1/3, so that's still just 1. And then y prime equals 0. So this is going to be 8 to the 1/3 is 2, and that 2 cancels over here. So I have 1/3 plus 2/3 y prime equals 0. So solving this equation, it looks like I'm going to end up multiplying over by 3/2. So y prime is going to give us negative 1/2. And so now we're ready to write our equation. We have y minus 1 equals our slope times x minus x1. And then for the normal line, of course, it's going to be the same thing, but we're going to have the negative reciprocal. All right. All right, now this is a common problem that comes up on the AP exam, and we're asked to find the second derivative, but we're asked to find it in terms of just x and y, and we're going to discuss that, and it's going to show up about in the middle of the problem. We don't do anything different. We're still going to do our derivative, and we're still going to have our y prime. We do need to solve for y prime in this case. So we're going to have y prime equals negative 10x over negative 4y, and definitely reduce this. So we're going to have positive 5 over 2 times x over y. We can look at it that way. That might mess up some folks. Let's just go ahead and say, well, that's going to be positive 5x over 2y. All right, now we're going to do our second derivative, which means we go through this process again. So we're going to have y prime prime, look at that. And we're going to have to do our quotient rule. So we have the bottom times the derivative of the top minus the top, derivative of the bottom, and that's all over the bottom squared. And this is going to be where we have to go back and solve out some things. Now this is going to give me 10y minus 10x y prime all over 4y squared. Now here's the problem. It looks like we might be done, but we're not, because we've got this y prime. And this said in terms of x and y. And this is where kids lose points on the AP exam. You know a value for y prime is sitting right here. Now once you make the substitution, you don't have to do anything else to the problem, but that substitution must be done. So we're going to have y prime prime equals 10y minus 10x times 5x over 2y. And again, don't do anything jiggy with it, just leave it alone. And that's all over 4y squared. So again, we have to start out with the derivative. So we're going to have 3x squared plus 3y squared y prime minus 9 times, in the product rule, first derivative of the second plus second times derivative of the first. And we're just interested in, and of course all that equals 0, just the equation of these lines. So we're going to substitute in 4, 2. Well, 4 squared, 16 times 3, 48, plus 3 times 16 y prime minus 9 times 4y prime plus 2. Make sure I didn't substitute in weirdness here. 4 squared, 16, yeah, plus 3y squared. Oh, I did right there. I thought I might have. Y squared is going to be 4, isn't it, today? And then minus, and that's going to be 9 y prime. All right, it doesn't look like I've gotten anything else, kind of weirdness. So we're going to have 48 plus 12y prime minus 9 times 4, 36y prime minus 18 equals 0. And let's see, we can put these together. That's going to be 30. And then move it over to the other side. So that's going to give us negative 30. And then over on this side, we have 12y prime minus 36y prime. So that's going to be a negative, looks like a 24y prime. So y prime equals 30 over 24, which looks like we're going to get 5 over 4. And then we can write our equation of our tangent line. So we're going to have y minus 2 equals 5 over 4 times x minus 4. All right, so same process again, but now we're going to use the 0.24. I wonder if they're going to have anything in common. So again, we're substituting straight into our derivative. So we're going to have 3 times 2 squared, so that's going to be 12, plus 3 times 16 y prime minus 9 times, and we're going to see, and oh, I didn't mention, we are plugging in right here again. So 9 times x, so that's going to be 2y prime plus 4, and all of that equals 0. So we've got 12 plus 48y prime minus 18y prime minus 36 equals 0. And let's see, putting stuff together, we're going to have 30 y prime equals, well, if we put those two together, we're going to have 24, and we're going to move it over to the other side, so it's going to be a positive 24, and we're going to divide that by 30. So now I have positive 24 over 30, and so what is that going to be equal to? We're going to get 4 over 5. Well, look at there. It did have something in common. Thought it might. So we're going to have y minus 4 equals 4/5 times x minus 2. All right, so now our next question is asking about a vertical tangent. And when you see vertical tangent, that means you have an undefined slope. Always think that, and then you'll always think about here, this is where the bottom equals 0 and you solve. So be careful with that. Every time you see vertical tangent, those are the things you need to be thinking. So we're going to take our derivative that we had up here, and we need to rearrange it to see, well, what's going to be in the denominator. So we're going to have 3x squared plus 3y squared y prime minus 9xy prime minus 9y equals 0. And let's go ahead and do a bunch of rearranging here. And so I'm going to keep these on one side and factor out the y prime. So that's going to give me 3y squared minus 9x. Everything else is going to go over to the other side. So that means we're going to have negative 3x squared plus 9y. And then we're going to divide both sides. And we're going to have negative 3x squared plus 9y. And all of that is over 3y squared minus 9x. Now we want to know at what point does the curve have a vertical tangent. So this problem is going to get pretty messy here. So what we're going to have to do with this in order to find that vertical tangency, and not all problems dealing with vertical tangency is this messy, we're going to take that denominator and we need to set that equal to 0, and we're going to solve for y. So we're going to have y equals, or we could solve it for x. Let's see what the original problem was. We'll have to solve for x. That might be the best route here. So we're going to say y equals, well, I'm going to add 9x over, and then I'm going to have to divide by 3, and then I'm going to have to take the square root. It's going to be plus or minus. So I have plus or minus, and 3 cancels into 9, the square root of 3x. So then what we would have to do is take this value and substitute it all the way back up into the original problem. And so that's going to be a ridiculous amount of work. And most kids, if you get this far, then you've got 2/3 of your points. So it's a good place to stop here. Now we can continue on, but for right now, let's stop here.